Hey everyone, how's it going? I'm recording. I'm recording. How's it going? I'm that guy, and I'm back again, trying to show you how to coding. Our tutorial has led us into the realm of, I think, episode 5 or 6, if I'm not mistaken. This is probably episode 6. We are going to add a couple of bricks for the collision detection, and then we are going to try and smooth out the frame rate. I had a couple of thoughts about it. I think at the end of the last video I showed you guys what things look like. Let's grab that over there, get on the screen. It did not look amazing. It was a little bit on the slow side. As you can see, it's incredibly slow. So my thought on this was, first and foremost, I think it's because it's using the same integrated GPU that I'm using for, OBS Studio. So my initial thought was that it's a little bit on the slow side because I'm doing screen capturing on the screen. And then I also thought about it a little bit more. It might just be slow because of the way I'm grabbing the DC every time each frame around. It might be beneficial to cache that DC. It might also be beneficial to look at how things are buffered. There's also a big difference between debug and release mode. Let's actually check it. Let's just check. We should have a valid configuration. It might not compile. I don't usually compile in release mode until like right at the very end. So they might be lagging. As you can see, immediately there's a lot better. Smoother frame rate. So in debug mode, there's all these kinds of bounce checking things that are done. There's all kinds of output that's done. There's lots of error checking done. There's also a lot of overhead inside the executable because of the way the debug variables work. There's a lot of stuff going on in debug mode, whereas in release mode there's a couple of optimizations applied. A lot of the debug information is just straight up left out. There is a way to switch on the optimizations to make this smoother, but I'm kind of happy with this for now, like a little bit. As you can see, the pedal's still not smooth enough for my liking. It just doesn't work for me. So I'm probably gonna try and get a little bit higher rendering if I can. Oh, I managed to bounce this thing off the screen. That's great to know. But there is a way to understand if it's off the screen or not, and then kind of reset the level. So I guess today we will try and switch on a couple of bricks quickly. My daughter is crying and I am almost invisible. I had to fiddle with the green screen because if I lean back then I become one with the screen. I don't mind being half invisible. It's actually a cool effect. But just know that there's this way my face is kind of off hidden inside this thing is because I had to filter the settings of the green screen a little bit. So I guess one of the first things we want is, you just excuse my daughter's crying. I don't know, it's late. She's probably moody. What we want to see is what is the speed at which the similarity on updates, right? And what is the speed at which it updates? What is the speed? Set timer 16 milliseconds. Now I'm not convinced that's actually 16 milliseconds that we're getting. The Windows timer simulations are actually incredibly bad at this. I would hazard a guess that we're getting probably closer to maybe. Well, I'd say we're not getting 60 FPS. I'd say that for sure. Excuse me. It's winter and oh, you can see my screen shrink through. Oh, that's cool. So it's winter and it's a little bit chilly, so my nose is a little bit on the runny side, like a tiny amount. My first thought would be to kind of just smack a thread at this, and then utilize the game loop like idea or strategy. What's happening right now is that we are using set timer to devote a portion of my Windows message. Excuse me. A portion of my Windows message processing is being devoted to, hey, let's also draw on the screen. So if we, let me just find it. There's the message pump. I think I start the message pump up like right as yep, here we go. While get message, blah blah blah, translate, accelerated translate message, dispatch message. The set timer thing causes a message to be queued into the message loop, into the message queue here for this window, so that get message continues to return true. But then also when you do dispatch message, I don't want to lie, I think when you do dispatch message or when you do get message, this on time is processed, right? So let me just think about it. There's a car driving, silly guy didn't bother adding his muffler to his vehicle. Okay, so the way this works is that you are actually passing your 16 millisecond resolution and your on timer callback into the Windows message pump, right? Windows is sitting there processing messages on its own thread. When it comes time for you to have been notified about this, if you didn't bother adding in your timer proc here, then you just get a WM timer message here that you could process and do whatever you want with. And because we are not processing that WM timer message, it's just falling through to the default window procedure. But what we did do is we added in a callback that gets called globally on the main message processing thread. This thing gets called globally. I think it's the same thread in which we process these messages. I'm not too sure about it, but what I do know is that if you are too time intensive in this thread, then you actually slow down things for your window. Now with modern processors and preemptive multitasking, CPUs have become a lot better at kind of stopping and starting and preserving states. You don't even notice that you're slowing things down, but you're actually slowing things down. Again, it's not like we're processing crazy amounts of inputs at any given time. We are moving a ball around on the screen. Well, what I do know for a fact is that this 16 milliseconds might actually be too fast for the set timer function. Now, if you want something interesting, you can use query performance counter, query performance timer, but you can't do that here because query performance timer, you have to actually poll what is the timer value. So if you do it here, you're probably gonna just lock things up, right? Because you're then never gonna relinquish a time slice inside here. So my thought on this is, let's spin up a thread, right? And then offload all the information for how to render this thing. Let's offload that information onto the next thread. Once we've offloaded that information, we can then most likely get a much smoother frame processing, because we'd be sitting in a dedicated thread and we can very finely control using the high performance counter and the high performance timer. We can then very finely control how much time slice is allocated. We can actually do a variable frame rate which says if what I've done takes more than the allocated time, start doing immediately, don't try and rest, right? That way we can kind of lock up one core of the CPU or one thread on one core of the CPU for a while, and we are preempted. But that would be the idea, that we get much finer grained control. And then obviously once we've done that, we can then add in instrumentation to figure out, to profile this and figure out what is it that's taking so long. If it's the drawing the rasterization code, we can probably get away with I don't know, maybe using a drawing library or simplifying things a bit. But I'm not too concerned right now, because we saw what it looks like in release mode. It's not crazy. It's not like it's incredibly slow. So I think for now, what we'd probably do is just carry on, get the game up and running, add in a nice game loop, and then afterwards try and optimize. Let's not optimize prematurely. Let's first figure out what it is that's slowing it down. So what I think at this point we had was a reasonable collision response. I'm guessing the way I actually saw one of these games the other day. The way that thing works is that it doesn't actually have a bottom wall, so you can't bounce off the bottom. If it gets past your paddle and goes off the screen, that's it, right? You lose one turn in the game. So I guess we can remove the bottom wall, if I'm not mistaken. We can probably just like dump it. That should at least give us a little bit more like closer to the realism that we would have experienced if we were playing a different game or an arcade version of this thing. if we remove the bottom wall from the entities list, I'm just thinking out loud. If we remove the bottom wall from the entities list, this will just never be true. But because this is an OR relationship, it should be fine for the other three walls. So my thought on removing it would just be to dump it from the simulation, right? But where did we actually put the simulation? Right, it's not all in here. We've got a similarity on file that we're using. cpp.h. Oh, this is horrendous. It's all in the header file. Yeah, I don't like that at all. There should be something called should be something like game.cpp or simulation.cpp. There should be something. Right, I'm not too happy with how that works, with how that's set up. I think it's fine for now. I think we've already factored this into its own file for now. But I'm not too excited about the way this is set up. What we should do is top left, top right part is comment out walls 3. Is that right? Oh, can't we just say 3 for the number of walls and then just comment up this explicit construction of this wall, because that relies on it being false. If we say there are 3 walls, it's left, top and right, and that sorts it out, right? Even then, num walls will iterate through left, up and right and then just do whatever it needs to do. So I'm happy with that. What we then need is something called a brick. The collision response of a brick is to call some kind of callback. I think that would be the most reasonable thing at this point, is to just call some kind of callback. I'm not a fan of lambdas yet, because there are some rules that are a little bit obtuse, especially if you're a beginner trying to learn C++. It's a little bit of obtuse learning the rules regarding lambdas. If you use a lambda function, if you're defining a lambda function, right? Is that the lambda? No, that's not the lambda. This is the lambda. I believe that's the lambda. That equal thing here means grab everything in the enclosing scope. So if you add something like if you did that, then you could use x equals 1, y equals 2, and it wouldn't actually be a compiler error, right? Or would it be? Expression must be modifiable. You do. See, I don't even remember these rules. There's a way to make a lambda work. There we go. Grab it by reference, not by quality. Which is a horrible way. Like, having to memorize this syntax? Nah, it's not for me. I mean, I can do it. I know how to use this. I just don't like it at all. It's horrible. Look at this. This doesn't even look like. Compare this, right? Compare that. Virtual void collision response. Collision type T. Collision edges E. Override. And then you define your function. Then you do your things. Like, you've got all the stuff that works. And then you get this, which you can't even read out loud. Please, I challenge you as a viewer, as a compatriot, as someone who watches this and follows along with my droning. I challenge you, read that out loud to someone so that they can describe it. Like, I can read this over the phone. I can read this to my wife and say, please type this over there on that machine, and then hit the compile button. It's a little green arrow on the top of the screen. You'll find it, right? How do you read this to someone over the phone? Square bracket, left square bracket, right facing square bracket, ampersand, left facing square bracket, parentheses, space, curly brace. That's garbage. That's garbage. You can just read this. I don't, as you can see, I'm not a fan of the way these things work. So my thought would be that they should be like a listener thing that you can add into here, that you can say, you know, I am a collision listener, right? And I care about collisions, and if these collisions happen and this collision response is called, if a listener has been defined, you can say, hey, this thing has collided and here's my type and this is the edge that collided, right? Nice and easy, instead of a lambda with like ampersands and gobbledygook on it. So I think that's kind of the direction we're going to go in. We're first going to try and define a few of these things and see if we can make something happen. I think I'm going to have something like I'm going to define like a brick broken interface, right? Like a brick broken listener, and the brick broken listener just gets a callback that's like public void brick broken, and then it tells you collision type and collision edge, and then that's it. So in fact, while we have this file open, let's just do it. Let's start typing. We run into like 20 minutes of how to coding, and we haven't coded yet. I'm just kind of like mind mapping what we're going to do. So we'll do class brick broken listener, right? And virtual void brick broken. So the listener should actually have, this should actually be on brick broken. It's an event, right? It's a brick broken event listener, but I'll call it a brick broken listener, virtual void on brick broken, and then it will just take these same things. I don't think we'll use all of these things, but I think these are worthwhile, right? So as a predicted variable, I'll have a brick broken listener star listener. I should be using m listener, but I think listener is fine. Want to just put that in the constructor, and then just put that there, and then if listener, then listener on brick broken de on brick broken. Oh, on brick pro. Why is this not doing the thing? Is inaccessible. Why is it inaccessible? Because that's not public. There, done. So now something can implement brick broken listener. I think that's going to implement brick broken listener is the simulation. This simulation, I don't like having it like this. Right? I really don't like having this like this. Like, for serious, I don't like it. Yeah, see there, no default constructor exists for class brick, so you can't even. Why can't I abstantiate? Oh, I've got a bricks numbricks. I'm just not throwing numbricks. Huh. Numbricks 200. This could just be brick star, just array of pointer. That should solve it. Update doesn't. I don't like all this update nonsense here. I think the first thing I'm gonna do here is I'm just gonna pull this out. I'm gonna pull this all out. I don't like how this fits together. Mouse needs to be its own thing. Auto brush needs to be its own thing. Simulation. Auto brush should actually be in utils. Why don't I have a utils column here or filter here? There's no utils. I should have utils auto brush. It's so light and throwaway that I'm kind of tempted to leave it here, but I should have utils auto brush. I should have utils mouse. I should have not struct simulation, class simulation, and then this should all just be split up into header and implementation file. I think let's just get through this. I can format off screen, or I can update off screen. Let's just get through this. Brick style brick. Public simulation, nothing about bricks construction. Let's just do oh no, build a wall, right? For int equals 0, I list bricks. Bricks. I equals new brick this, and then I'll have to go through in a doubly nested loop later and do set values on each thing, because in my mind I'd like to do them in rows, right? I could do the I could do the logic here for how many rows and columns I want, but I think, should I construct and then just set value? Probably. So similarity on should just become a public brick broken listener, and then there's a way to actually just say implement these methods. Just go find brick. Yeah. Implement this. Right? And you'll see the reason I implement this is because it's going to be so easy to actually handle this, right? In my mind, basically what you'd have is, you know, on brick broken, we guarantee that the brick is broken at this point. A brick needs to have some kind of state. Void set visible or visible. This visible. Let's just do that. Oops. Visible, and default for a brick is true, right? And then what would happen is, if there is a blah 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 and a collision, then visible equals false. That's all a brick knows about itself, right? In fact, should a brick, yeah, a brick knows it's colliding, but a brick's collision response should be dictated by the parent, because then you can have multiple taps to release. Maybe to change the color, like in Mario Bros. If you bounce against those solid blocks, there's stuff hidden inside, right? Some bricks should be unbreakable. So what would be the most pertinent thing would be this, right? So you'd have something like class brick star b, right? This de, and then this thing doesn't care about visibility, it just knows its default visibility is true, right? Boom, visibility, visibility. I don't want the brick to have logic inside of it, if I can put it that way. I want this to just hold state and perform callbacks, like just blindly hold state and perform callbacks. That's why I'm doing it this way, you know, construct it with some default visibility. Don't just smack a default in there, make it configurable from the outside. So do the brick listener, get the visibility, hold that state, and then don't alter the state unless told to alter the state. Don't just all willy-nilly alter state. Perform dumb callbacks. Say if there's a listener, just tell this thing that, you know, something happened to me, right? Simple. So then what happens is, over here, when we construct this, we can actually say, yes, you know, the default visibility state for a brick is true, right? I'd like to say bricks I set values to, you know, x, y, brick width, brick height, dx and dy are always going to be 0. So I'm going to define x, y with height. We'll do some logic for this, make that happy, and then here we're actually going to build the wall. We just never bothered to do the bricks. Interesting. So we draw we fill the, I'm just reading this thing from top to bottom. We fill the screen, we draw the walls. I'm not happy about drawing the walls, but we draw the walls, we draw the paddle, and then we draw the wall. So let's do it. We fill the play area with this black brush. Then we draw the walls. Then we draw the bricks. Rect b equals bricks. If I could type it, that would be amazing. Bricks I arrow x. Can't I just say bricks I arrow? Copy and then override all of this. Yes, I can. As you can see, my mouse flow is not great, so I don't usually work with a mouse that much, but sometimes it's necessitated by just rushing for time there. All bricks thrown. Okay, so we throw the bricks, and then we do get the paddle and throw that, and then we do get the ball and throw that, and then we throw everything, stretch it onto that main buffer. Okay, great. So you're on brick broken. This actually doesn't override anything. I'm very interested why we're not getting an error here. Maybe the compiler hasn't figured it out yet, but there should be an error saying that this doesn't override anything. If I do that, it should complain. There we go. Now it complains. So what I want is a brick star brick. Now it overrides something because this definition has changed over here. It contains brick star b now, right? So that's the offending brick now. So what I can say about the offending brick is b set visible false. I want the score to update. Score plus equal 10, some arbitrary value, right? I don't care which edge, which type of collision it was yet, because the collision type is always going to be brick, so I know what that type is, but I do want to hide the brick and then increment the score, maybe play a sound to something. But what's nice is that inside here you can check are all the bricks broken? Yes. New stage, right? Something like that. You can actually fiddle with the game loop at that point. So what we need to do then is we need to fiddle with this logic, and we need to just add in a variable for score. I think it's just going to be an int score. It's going to start at 0. I don't like all of this here. This code is it's in source control, so I can stand to get rid of some of this a little bit, just to shorten my scroll time. You can see I'm scrolling with the mouse. It's not a pleasant experience to sit, scroll. So I think here where we create a similarity on, we shall set our score. I kind of want to explicitly set the score to 0 right here, just so it doesn't look like a baked-in score and it's not an afterthought. Like the baked-in score of 0, I don't want to just like hard initialize it there. I want to put an explicit thing here that says the score when you start is equal to 0. Okay, so let's figure out something. I have 200 bricks. Do I want to work in rows and columns, or do I just want to do like here's a dedicated just like flat list of bricks? Doesn't really make a difference. Let's just do a dedicated flat list since we wrote all the code already. Let's not backtrack on that yet. So let's just think about how are we going to do accessing a grid of values, having only like a first we know there's 200 bricks. So what I want to do is I want to say I want maybe 5 rows of 40. Yeah, let's say 5 rows of 40, since we know it's 200 is hard defined. So I want 5 rows, right? So num bricks and num brick rows is 5 rows. You can get that 40 by just doing the division, right? Let's get that by doing the division. So now we know there's so many brick rows. So I want to say int num bricks per row equals num bricks divided by numbricks rows, right? There. So I know how many bricks are going to be on each row, and I know how many rows they're going to be, so my iterating becomes easier. I'm going to start with, I know the width of the simulation, right? And I'm starting to think it shouldn't just be this like generic width height, it should actually just be hash defined here, because it is constant. There's no reason to make it constant. It should just be an hash defined, right? So let's just create that hash defined. So hash define simulation. Oh, what on earth did I do? Where's this button? Hash define. What the heck? There's something weird going on there. Simulation, what simulation? Height, CS, let's just take those. Is it even used? Yeah, here we go. Simulation width, simulation height. There should be a few more of those. Here we go. Simulation width, simulation height, and then simulation width, simulation height, simulation width, simulation height. Oh yeah, much better. I love this color. I'd like to sprinkle more of it over my code, just like politely use the hash defines correctly, right? Because I mean, these are constants. If you fiddle with them, then some of the logic breaks. So it would make sense to just hash define them, and whoever messes with them has to not only go find them, but they then are forced to know what they're doing, right? So yeah, I'm happy with the idea of hash defining these. Simulation height. I'm not feeling too well today. I'm not sure why I'm not feeling well, but it's might be a little bit of a chill I picked up. It has been winter and it has been unpleasant. It's been a difficult time. In fact, I think it was last week, the week before, I ended up on the roof with these guys doing waterproofing. Because I don't know what happened, but there was this big leak in the bedroom, and when it would rain, as it does in winter in Cape Town, you'd hear this thing just drip all night. We had to eventually just get like a 20-liter bucket, because when it rains hard, the bucket would fill up. It was that bad. So we got these guys out as like a kind of emergency quick fix, like, guys, please help us, because it's kind of just raining almost straight into the room. And then they came up and they said that the along the joints, the weather moved the stuff and caused the joints to widen, and now water is coming through, so they put new screw things in, and then they put this like thick tar sheet, and then they melted it on with a friggin' propane torch. It was insane. It was actually quite fun. But part of that, while they were explaining it to me, they had me on the roof, they were showing me this is what they're gonna do, and then I got caught in the rain, like a heavy downpour hit us. So yeah, I think I caught a chill at that point. Like, ever since that time, I've been feeling a little bit off. So I think it's finally now coming to a head where my body's saying, "Hey, listen, guy, you are definitely sick." You know, previously we were kind of working out easy, isn't it? But I think at this point, it's like it's confirmed now. I got wet, I got soaked in the rain, and I'm sick now. But I should be able to get this out quickly. Numbricks per row, numbrick rows, int brick width equals. Oh, this is why I was doing it that way. Simulation was divided by numbricks per world. Can I just, there we go. define the wall within a height, right? XY width, simulation height. So this is wall width, right? So it starts in the top left, wall width, simulation height. Then the top wall is top left simulation with wall height, right? And then the right wall is top left is simulation width minus wall width. XY width is wall width height to simulation height. Top x and otherwise 0 0. So guys, I just found another thing I have to define that makes sense, because if you want to fiddle with it, you can actually just change this to like 4 or 6 or whatever and still have like a decent set of things that you have to actually go and worry about changing. So the obvious thing is actually define it. It should be constant, excuse me, but if you want to change it, it doesn't go breaking the simulation. So let's go. Oh, remember I said like 10 minutes ago that I like all this purple? Yeah, it's working for me. I think one of the things I noticed for the last video was that the number one, that thing was like covering off the screen, and number two, my recording kind of just stopped here. Like it cut off this off piece of screen here and that piece of screen. So whenever I'm talking about code, luckily my default setting is to try and scroll things into view. So like most of the code was like luckily just kind of in view here, but still it was weird. Like I didn't set it correctly or something. I think every video will just make this like bigger and bigger and bigger until it's like one letter takes up the whole screen. So we got numerics per row, numerics divided by numeric rows. It's 200 divided by 5 is 40 per row. The brick width is the simulation width divided by numerics per row. Minus wall width times 2. That only works because wall width is an integral value. If it were a floating point, that would just completely destroy it. But yeah, that's minus the 2 walls on the side, and then our do we have something called x here? We're not inheriting from anything. We don't have a member called x, so I can safely define something called x here. X equals 1 wall width, right? And int y equals 1 wall height. That should give me a way to say let's modify the x and the y, right? So brick width is that, and the brick height should change by the brick height should have the same ratio of width to height as the simulation screen. It is 320 by 240. What is that? 4 to 3. It's 4 by 3, right? If you divide 320 by 60, that's 4. If you divide 240 by 60, that's 3. So it's a 4 by 3 height. So whatever brick width is, it should be 4 by 3. How do you get that? Let's say brick width is 4. I want the height to be 3. So how do you do that? How do you do that? Let's say you do float pw equals static cost, cost float brick times 4. What do the promotion rules look like for C++? I don't think it'll cost that. I think it'll uncast that. So I need to make that a float and then divide it by 3.0f. So it's 4/3 is our aspect ratio. So if I just multiply by 4 and divide by 3, I should get it, right? So if I say my current brick width is 4 and I want my height to be 3, so 4 is 4 times 4 is 16 divided by 3. What is 16 divided by 3? Not 3. Let's get the calculator open for this. This is something silly, right? 4 divided by 3 equals 1.3. Times 4. 5.3. It's clearly not right. Oh, is it backwards? How do clear all? I want 3/4 of that height, so it's times 3 divided by 4. So if I say 4 times 3 divided by 4, yeah, silly. Times 3 divided by 4, done. Let's try that with 8 different numbers. 40, let's try 40 times 3 divided by 4, 30, yeah, done. Good. I just had these two swapped around, so now I can do int brick height equals static cost int bw. Oh, I'm thinking of DW. I thought there's a theme song for BW, but no. There's a theme song for DW. Equals Darkwing. I guess you all know this theme song, right? Darkwing Duck. When there's trouble, you call DW. Darkwing Duck. So now we've got our brick height. Right. Oh, no, that's not at all how I define a brick width and edge. Now what I want to do is I want to say advance the x until oh no, just the current brick count equals 0. It's much equals 0. Brick plus plus if current brick is greater than bricks per row minus 1, then current brick equals 0, x equals all y plus equal to brick height. Right, so now we do that plus plus x plus equal to brick width, and y does nothing. Y advances as it goes off the end of the row. Y advances. I guess that kind of sorts out brick. Right, set values x, y, brick with brick height 0, 0, and then we fiddle with the values and we go through the loop again, plus plus, do a check if we've hit the end of the row. You can actually also just, it's much easier to just do if it equals that, like it starts at 0, when it gets to bricks per row, just drag to the next row. That should solve that. And now we should have bricks, and we also should have collision detection. No? New, what errors do I have? Brick is, oh, silly me, this visible blur. Oh, and the bricks are all squished up at the top left of the screen. We'll figure this out. Is my brick width not right? It's also not removing. I think what's happening is, let's just see. Y equals wall height, y plus equal to brick height, x plus equal to brick width. And my brick width is simulation width divided by number x per row is number x divided by number x per rows. It's 200 divided by, that's 40 bricks per row. Brick width is width divided by number bricks per row. Some 320 divided by 40. Which calc? 320 divided by 40 equals 8. Okay. Oh shoot. Simulation. That's what's wrong. This is incorrect. I should say simulation width minus the width of those two walls, then divided by those number of bricks per row. Alright, simple. That's an easy one. But the height is not right. So, oh, because I'm using brick width, which is all like already busted. Okay, that's fine. So if you make a mistake further up, then it just destroys it. That's a little bit better, not great, but a little bit better. Let's see. My number of rows is not right. It doesn't look right at all. It is bouncing where it should bounce, so that's encouraging. This paddle movement, it is bouncing where it should, but it's still not right. So let's go through. Let's actually just debug it and see. I'm a little bit on the tired side today. Bricks is 200 bricks divided by however many rows. There's 5 rows. Right. So let's just get the locals window up so we can actually see what's going on here. Let's just dump that down a bit. Where's our code? There we go. So bricks per row, if 10 gives you 40, right? Bricks per row 40. Brick width is simulation width 320 minus 2 times 2, 320 minus 4 divided by that 40. So I expect to see 7, yeah. Brick width is brick width times 3 divided by 4, so 7 times 3 is 21 divided by 4 is 5 point something. It's 5.25, and then brick height is just static cost to the end, so it's 5. Oh, but that 0.25 adds up. It adds up like 40 times 0.25 is definitely gonna affect it. So what we should do is take values that are better divisible, right? 320 minus 4. If I just say I want 180 bricks, let's just do that math quickly. 180. Let's just refresh that. Let's just track. I want that error to be a little bit lower, and I want the bricks to be a little bit bigger. It's easy to check against the ball if they're bigger. Bricks per row is 36. Brick width is 8, and brick height should be 6. There we go. Let's try. Let's look at it. See if it actually does the thing. A little bit better. I'm definitely not liking this. What is this? Right? Here's something interesting I want you all to see. I want you all to just look at this. The fill rect function fills a rectangle by using a specified brush. This function includes the left and top borders but excludes the right and bottom borders of the rectangle. Oh, but that should only get me x squared plus height. You should only have to do +1 and +1 there. That's all. That still doesn't explain why I'm missing a bunch of space at the end. Should it be greater than? Okay, let's be fair about it. Let's say I want 180 and then I want 4 rows. Right? So what's happening is if current bit greater than bricks per row, current bit equals 0, do the thing. Okay, that's fine, that's fine, that's fine. But now what I want then is, I want to say I have something I can divide by 5. Say 100, let's just fiddle with it. I want something that's divisible by 5, even if I just do like 20 bricks per row. You see that? That's better. But it's not evenly divisible. See, if I say I've got 100 bricks, now on 5 rows, that's 20 bricks per row. Why is it not in the thing? Let's see. That's a height. That's 1, 2, 3, 4, 5. Oh, it's running over. What I should do is have 4 brushes, right? Actually, let's just have the 4 brushes. It's gonna make it much easier to debug. So it's x, y, put brick height, right? And then it says plus, it goes to the next brick, and then it says x plus equal to brick width, so it moves to the next brick, and then it says current brick is greater than number bricks per row, no, then it should do nothing. So it goes up and it says set the values x, y, brick width, brick height, and it goes to the next brick, goes to the next, and goes to the next, and goes to the next, and it says x plus brick width, and it says current brick is greater than number bricks per row. Yes, the current brick equals 0, and x equal to the wall width, so reset x, right? And then y plus equal brick height, and it goes in, it starts on the next row, and it says go plus 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 plus. So all I need is, I need to say if I have, this is such an interesting thing, I should get 820 here. Yeah, I should get 20. So it's 20 bricks per row. I actually want that to be 10 bricks per row. It's going to be much easier to debug. Let's just make that 10 bricks per row. Let's say this is 50. Right? And there's 5 rows, so that's 10, 10, 10, 10, 10. And then it's independent of the wall height and the wall width and everything, right? So let's just debug it very quickly. I don't really have that much time. We can clearly see that's off by a lot. There's a bunch of bricks missing as well. I want the brick to have a brush. Yeah, I want at least 4 auto brushes just to see the different bricks. I can just like manually count them. Auto brush 4, just 4 brick brushes. How do you define an auto brush? With a color F equals, I know this is terrible, but you should be able to say equals should that work? No, it shouldn't. Yeah. Should that work? Yes. I don't want a red brush for this thing. I want let's just do something funny. Let's make that. Oh, what did I do? Let's make that green. Blue. Some color and some other color. Oh, not 0, not 2. Okay, great. So 1, 2, 3, 4. How's that last one mounting? It should just work. Yeah, stop mounting. Oh, I completely missed that. Okay. So now I got these brick brushes. All I want to do is when I draw them, full brick brushes. I'm what 4 dot. Okay, that should give me a repeating the value of brick brushes, right? 0, 1, 2, 3. Brick brush. There we go. Much easier to see. So let's see. Something's obviously very much wrong there and there. Right. So we can clearly see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's exactly right. 10, 20, 30, 40. Oh, but then 1, 2, 3, 4. There's my last 4 missing ones. Okay, great. See, much easier if we can see what we're doing, right? I'm so happy I defined. Sorry, I'm so happy I defined this auto brush thing. It lets you create a brush very easily without having to worry about selecting, doing all kinds of weird things. So yeah, that's how you use auto brush off to find it. I'm very happy that you can use a solid array of auto brush for this. And nose stripping a little bit. So what we can clearly see there with that logic is that's wrong. You can say greater than equal. It should fix it, but you'll get your 5 rows now. Or equal its first. There's your 5 rows. I don't like how this is jumping around a little bit. It's integer rounding errors. It's not right. Not pretty. What we should do is I want a pretty pattern, right? So we should fiddle with the way we access this thing. We should probably have a every once in a while okay, I don't care enough about it to worry about it right now. I just want to get the simulation working. So what I should do is I just want to check, is that a definite, it's not a 10 pixel gap there, right? Also the simulation, the collision response is not right. Oh, I know why. I know why. I know why. I know why. We need to a collidable. Right. we can change the visibility, but we can't change the interactivity of something. That's what's happening. So here where we create this, that's the checker with the collidable. Where we create this collidable, we should say that this interactive is true, because by default all things are interactive. But then as you fiddle with them, they change to non-interactive, right? Simple as that. But this again just holds state. It tells you if it's in range of other stuff, but it holds state. The checker should actually check, is this thing interactive? So if currently entered add x equal I, continue, or if current entered, if no input is I dot interactive. If it's not interactive, then continue. That way it doesn't bother taking collision detection checking. It goes check the current one against the next one. Alright. Check the current one against these ones, and if they're interactive or not, do nothing. Right. I can see a subtle bug here, but if currently interactive, whatever. I'm not gonna fiddle too much with it, but I think that if this thing, right, if not that interactive, also continue. So if the one you're checking and the one you're checking against, either or, are not interactive, then just skip, right? I think that's what should happen. And a subtle bug, not. There we go. So that gives me a way to say in the simulation, I cannot get used to the fact that this is in a header file. It's just getting to me. In simulation, we say if break I visible, is that not reachable? Visible, visible, set visible, void is visible, void, nothing. We just leave it empty for that. I think we can just mark this as const return visible, right? Return visible. Return type does not match, no, whatever. I'm gonna fill with const correctness. You have to const cast that thing. Come on, do the thing. Just, pull. You don't have to const cast it. I wanted const. I want to tell the compiler that I'm not modifying this thing, so it's a little bit faster to return this. That's all. Is visible. Can't I just say if it's not is visible? Just skip over to the next one, right? One day I'll learn how to type. One day I'll be a big boy who types, right? So yeah, when you break the brick, the collision response comes back and says yes, you know. Your score plus equal to 10. You set your brick invisible, but also I want to say B interactive is false. And then if you get to the end, yeah, there should be a check. If you get to the end here, then it should say, oh, you know, something. What I want to see though is, oh shoot. If it's not is visible, continue. And when I construct my brick, I say it all is visible. So why are you not doing the thing? Oops. Is it going? That's very concerning that all of them are coming through. Ah, set visible. Oh, what are they colliding against? Are they colliding against each other? Oh, so this is easy. If E not equal to collisions 1x or then return. Like obviously you can't collide against other bricks, right? It's such a weird one that it's colliding against walls and things. Let's see. Should go to the, yeah, there we go. Now that you have the visibility checks in, it actually make look. Once it goes off the edge of the screen, that's kind of it. Oh, let me just put that bottom wall back while I'm testing. That's hilarious. 4 and then just undelete, uncomment this thing, just leave it in for debugging. That is hilarious. That if you're not paying attention, shoot, no, stop. It's not gonna build. No. Shoot wall width. No. Similarity on height. And similarity on width. Minus xy. Similarity on height. Minus wall height. And then similarity on width. And the width is wall width. Because for some crazy reason I decided to take the wall out before I was finished testing the collisions, finish updating the paddle, and now if I miss the ball, there's no way to actually see if it hits the thing or not. Oh, there we go, there's the visibility set. I should see, see I would have missed that because the breakpoint interrupted me. Let's see. There's something missing here. There's something very obviously missing, and that would be the oh, that's such a pretty bounce thing. It does the very correct thing. So one of the things I think are missing is my width and height check is not exactly correct. Right? I did 100 and 10 as the width, but the width it's not an exact value because I'm subtracting 4 pixels from it, right? And that's not right. We're ending up with rounding errors, so you can literally see the rounding errors over there. So what I should probably do is just have I should do better math. Just to kind of get beyond the point where it is now, I should do some better math, and that better math would help me eliminate the rounding errors. I think I'll think about it a little bit more and show us in the next episode. We'll do how to get better thing. I think the only thing that I'm really interested in doing for now is just kind of drawing the score on the screen somewhere so you can actually see how many points you have. I mean, it is intuitive. You look like you're about halfway through, but I think one of the interesting things is that I want to have a way to show the player like how much score they have. Theoretically, you should have number of blocks times whatever each block is worth. I think I made it 10 points, so you know, number of blocks times 10 is 100 blocks. You should be able to get to 1,000 to clear the stage. So I mean, it's possible. I think I'll just throw the score maybe bottom right of the screen. Where did I do it on the JavaScript ones? Was it? I can't think where I put it. It might have been top right, bottom right. Doesn't matter. So I guess what I'll do is those things, and then next time we can we'll just do the score quickly, get the score up on the screen, and then next time we'll come back and we'll say Oh, washing machine's done. Next time we'll come back and we'll try and add in that little check that says, have all the bricks been broken? Yes, you are. Well, winner, right? So for now, I think the only thing that's still left in this few seconds we have left before I'm kind of forced to kill the video is we need to get the score on the screen. I do want a starting state. I think we'll add in game states next time. We'll just do the starting state where we say did this player, is it in that initial state where you're kind of just sitting there looking at the screen, you haven't done anything yet? If it is in that state, then we should probably just wait for a mouse click, right? We should definitely wait for a mouse click. Give me a second. So what's next? I don't actually have to move the paddle, right? So what's next? I'm really trying to think what to. Okay, while that happens, while that game plays out, let's just get the score on the screen. So in the simulation, we've got the score. Let's just throw the score somewhere. I think that's creating bitmaps. Yeah. Can't we just say, kind of say, throw text onto my DC shoots score. When the score changes, I should do string ss score score scores equal ss dot right, and then I can throw text score dot c come on, int cch text score dot size, and lprc I guess is gonna be like the I should probably just define a rectangle here. Rect sc score equals I'm just gonna do it on the top left of the screen somewhere, so I'll do wall width times 2 wall height times 2 width. It's just gonna be some just make it like 200, height 80. Obviously your score shouldn't be that much, you can't literally get it, but just for the sake of having a definition up here that kind of takes care of whatever we need to take care of, we'll just do it like that. I don't know what that format is. I'll just put 0. I think it's dt left, yeah, dt left, dt top. Nope, that left is a line left, a line right, or a line middle. You've got dt underscore. Oh, it just suddenly doesn't like me anymore. Okay, cool. So what I should define is a int score and instead string score str. These things likely construct themselves decently, and I should have hash includes string is string string. There we go. So now all the strings and string strings and everything should be fine. What I should probably do is make this a function, right? Update score. I need that function to be uppercase. Void update score. There. Much better, right? Because now I can call update score while score equals 0 and not just have it randomly arrive on the screen. So yeah, where we say score equals 0, we say update score. So wherever we affect the score, we just do update score, right? Nice and simple. Let's see what that looks like. The ball is bouncing around on the empty screen. It's kind of what I expected. Just wanted to leave it running while we do it, just to see what it looks like. There we go. Set back mode transparent. Right, let's just see. We create our DC here, right? So we can just say set back mode DC transparent, right? And then what we need to do is we need to what happens when you draw text? You set text color. What do you set? Text color. DC color. No, not color. Just do RGB. I kind of want something close to like a nice pink. So R192 6492. Let's see what that looks like, right? You should only set back mode and text color once, because you're holding onto the DC, you're not releasing it and getting it back, so you don't have to set it over and over. But yeah, there's a nice big score and a transparent background, and the text shows up horrendous. I should probably just not set back mode there. But yeah, that's roughly fine. It's the beginning of a game, right? You can collision detect things, you can interact with these objects, you can do what you need to do. I don't like how things jump around. Like I really don't like the control scheme. It's super slow, right? I very much don't like it. It takes 5 seconds for this thing to travel the end. In fact, it takes 10 seconds to travel to the end. So I guess as the next step, what we can do is I'll probably move the score down to the bottom here, right? Yeah, I guess move the score down to the bottom. It's going to be a little bit easier to have it down at the bottom. I know traditionally you put the score in the top, but it looks terrible there. Probably also just change the color scheme for drawing the rectangles. I think that can definitely work. Next time, just debug this a little bit. I think I know what's happening, but I don't want to speculate on it. But I think what's happening is when we subtract these 4 here for the walls, it's actually just saying nope. I don't want to play because that 4 pixels are missing now. So if we find some value that's evenly divisible, then we'll get like a reasonable looking thing. I guess 100 is just not evenly divisible with that. We should do 320 minus 4, right? Let's actually see it. Let's do it. 320 minus 4 is 316. 316 is 31.6. No. 316 divided by 20, 15.8. Yeah. 316 divided by 15. No. 316 divided by 16. 19. 316 divided by 15.8. 316 divided by 115. I do 21. 316. I don't think this is divisible by anything useful. Because it's not divisible by 10. It's not divisible by 20, 50, 50, 50. It's like it's not. Is it divisible by 8? No, it's not even divisible by 8. It's not even divisible by 8. It's just it's not an easily divisible number. Like there's no. So what's the closest square divided by 21? So if I 21 the block is here, I'd incur like 1 or 2 pixels worth here. So if I 21 over here, 21 times 5. It's 105, right? Yeah, 105. I don't like it, but I guess it will work. Let's just see it. It should reduce that little margin, right? I don't like it, but yeah, it reduces that margin. It also makes a little bit on the tougher side. I like it though. In fact, I like this better than anything else. The only thing I want to do next before I sign off is just move the score down to the bottom left. With simulation height minus height minus 80. Let's just try that quickly. That's very compile. Simulation height minus, let's say minus 60. Let's see what that does. X, oh, y is x, y, simulation height, right, minus 4 minus 60, and then width and the height of this rectangle is just going to be 60 pixels. Should solve it. Sorry, I'm looking at the wrong thing and thinking 60 and thinking 80 and thinking all kinds of like weird values where I should just be looking at the y component of it. So let's see, that's simulation height minus, oh, is it going plus? Huh. Let's just do that. I shouldn't actually care about wall height, I should care about that paddle location. So if I'm using for the paddle y, what, x, y, what height? X, Y, TTF left, yeah. So why is that off the screen? Like, it doesn't make sense. X top. Let's just go look at this rect structure quickly. I could just be left. Left. That's not TRBL. It's left top right bottom. Silly. Left top right bottom. Left is that's x, right? So that's somewhere. Y is that's halfway through the screen, right? Right is this, and 200, and bottom is, yep, bottom is above top because it's not height, it's absolute bottom and top. So the height is actually going negative, which means don't throw in that rectangle, it's inverted. There we go. So now we can actually say minus 60 and then leave simulation height there because that ends at the bottom of the screen. Okay? And then see if 60 is too much. 60 is definitely too much, maybe 20. Come on, select a little piece. Such a nightmare. So as you can see today, I didn't talk a lot during the video. It's kind of, there we go. Oh yeah, that's beautiful. I was kind of just more focused on, you can still see everything. I was kind of just more focused on getting this done right. So I'm super happy with it. The shape of things, yeah, that looks so nice. And even there, that tiny little margin is just our rounding error. We've reduced it by just making sure that this thing is like almost evenly divisible. What we can do is move it, we can move it over by 1 pixel if we want to kind of remove that pixel. In fact, I can show you this trick. I've learned this from, we take whatever that rounding area is and we say x equals wall height plus 1 pixel, because we've got a 2 pixel rounding value. So x equals wall width plus 1 pixel, and that should solve it. It should give you an even amount of gap on the left and on the right. Let's see it. Oh, it's not an even amount of gap. Oh, that's terrible. So our gap is like, it's less than a pixel gap, but it's manifesting itself as a 1 pixel gap. I'm tempted to kind of just leave it as is now. It's better having the gap on the left than on the top. Oh, I just bounced that thing completely out of the arena. That's fine. I guess if I just move this up a little bit, it won't bounce over the arena. In fact, I should move it up to compensate for the score being down here. And I think all the games I've seen so far, this has been a little bit closer to the top. But that is a problem for next week. Thank you very much, everyone, for watching. Have a lovely week and a lovely weekend. Today, you got lucky. You got 2 videos in 1 week after an 8-month hiatus of me just not finding time to do it. You can actually hear my daughter over there. I'm gonna go spend some time with her. It's 9:30. Her bedtime is coming up soon, so I think I'll just go and chill it out. As always, the information, the repository, I'll commit all of this. The code will be available in the repository, linked in the description. It'll be github.com/howtocoding/cpp or something like that. But yeah, just go to How to Coding. You'll see there's like 1 or 2 repositories there. That's me. That's the stuff we're working on here. You'll see one in JavaScript that has some of this stuff in. You'll see this one that's becoming a little bit long and complex, but I think the end result is worth it. So as always, stay safe and stay strong.